Good morning, everybody. Mr. Samir Awad with you for today for grade 7 session of science and the lesson, chapter 4, lesson 1, what is energy? So let's start to ask ourselves a question. Every work you are doing every day, you need an energy for doing that work. And so we can say that energy and work are two faces of the same coin. So if we start to do that, we can say that energy is equal to work and both measuring units are, or for both measuring unit S can be joule. And we can say, guys, power is the work or energy done per unit time. So how many or how much time you get in order to finish this work or in order to transfer this energy is called power. And the power unit is watt. And also, we can say that watt can be the energy unit, which is joule, divided by the time, which is second. So watt is equal to joule per second. Let's move further, guys. Which of them has more power? We can say that we get one with electrical shovel and the other is getting manual one. So the one who's doing more work in less time, we can say that's getting more power. So the one to the left who is using the electrical shovel has more power as it's making more work in less time. So let's move to the main two types of energy. We can say its kinetic energy depends on the motion, that the energy for the motion of the object, and it depends on two things. If the object is moving, so it's getting a speed, and if it's called as an object, so it's getting a definite mass for it. So the kinetic energy depends on the mass and the speed. And the other type we get, guys, is potential energy. And from its name, potential, it depends on the position that acquired by the object. And it depends on two things in the weight. One of them is the weight, and the other is the height. So if we get the weight in Newton and the height in meters. Let's move to the first one, which is kinetic energy. And we said before that kinetic energy depends on the mass and speed. So if we get the three objects here, which is red car, blue car, and the bike, which of them can get more kinetic energy? Yeah, exactly. It will be the red car because it has more mass of the bike, and also if it can get the same mass of the blue one, but it's getting more speed than the blue one. It's getting 30 meters per second. For that, the kinetic energy for it will be more. If we get to the rule of kinetic energy, we can say that kinetic energy equal to half of the mass times speed squared. Speed must be squared. And for example, we'll get that example for a girl who's running with her dog, and the dog mass is 20 and the girl mass is about 60, but they have the same speed running 2 meters per second. Let's see what the kinetic energy for the dog and what the kinetic energy for the girl. The kinetic energy for the dog will be equal to half times the mass of the dog, which is 20, times the speed of the dog, which is similar to the speed of the girl, 2 meters per second. So it will be, by the end, 40 joules. And for the girl, it will be half times 60 times the speed of the girl squared equal 120. So here, guys, we'll see if the speed will be the same. So it will depend on the mass. So the mass here will make the kinetic energy increase as the mass increase. So if you double or make it times 2 for the speed, guys, of the dog, the kinetic energy will increase for 4 folds. Why? Because the speed will be squared. So the 4 squared will be, guys, yeah, excellent. Will be 4 folds of its kinetic energy. In the beginning, the kinetic energy of the dog was 40 when its speed was 2. But when we change the speed into 4, we doubled it, the kinetic energy becomes 160. So it's 4 folds of the 40 in the beginning. Let's move further, guys. Potential energy, yeah, we get it. That second type of main energy, we got it. We get first kinetic energy, and second is potential energy that results from the position or the shape of an object. So according to position, we can say that we have gravitational potential energy, and according to the shape, we can say that we have elastic potential energy. The gravitational potential energy, guys, is the energy according to the height or the position of the object itself. It depends on two things. It depends on the weight and the height. So on the other side, the elastic potential energy associated to the object stretched or compressed. So that depends on the shape of the object. Let's move further. For example, guys, that's example for the gravitational potential energy. If we see here what is the maximum gravitational potential energy here, it will be exactly for this one to the left. Because of why? We said before that gravitational potential or energy equals the weight times the height. So if we get back, guys, to that slide again, this one is getting 600 weight, and also this girl is getting 600 too. But the difference between them is depending on the height. That's on the height of 4 meters, and the other one on the height of 1 meter. So it will be 600 here times 1. It will be 600 joules, and here it will be 600 times 4. So it will be 2,400 joules. So that's making it get the maximum gravitational force because of weight and height. On the other side, the one here is 400 and getting 4 meters, so it will be 1,600 joules when I make it multiple, but it wouldn't be the same of this one. That's the maximum one. So the potential energy for this person, will be weight times height, 600 newtons times 4 meters, so it will be by the end 2,400 joules. And last but not least, the elastic potential energy, it depends on the stretch of the object. For example, here we have the trampoline here, and the trampoline, we have three positions for the trampoline. Which one is getting more stretched here? If we will see the one, number one will get the most stretch here, and number two will get least one, but on 3, the stretching will be 0 for the trampoline. So the potential energy in 3, or the elastic potential energy exactly, will be 0. But in 1, it will be the maximum, and in 2, it will be the least one. Thank you for listening, guys. Grade 7. Your homework will be sent to you through Pearson Realize. Please check it and start to answer it. And also, don't forget, if you get it soft copy, just start to print it, solve it, and picture it, and send it to me back, inshallah. Good luck for all of you. Be safe at home.